All right, so looking at 8.3, this is actually in two parts. So the first part is day 1, and then we'll do day 2 tomorrow. So day 1 focuses on logs. So we're really diving into logarithms. Okay, so first off, the definition of a log, you have y and b being positive numbers, with b not being 1. And the log of y with the base b is denoted as log base b y. Okay, so that's how we would say that, log base b of y. Okay, so typically we write it this way, and this is a big part. We can rewrite it back and forth with logarithms and with exponential functions. Okay, so this is what I will refer to as the heart method. So it goes that route. So if you follow the way that I just drew that heart, base b to the x equals y. And that's how you would rewrite it over here. Okay. And it could go the opposite way if you're writing it as a log. You do base b, log base b of y equals x. Okay, so it just goes back and forth. Essentially, all that's really happening is the base stays where it's at. The other two things just switch spots. Okay, so note for each logarithmic expression, there are corresponding exponential expressions. So they do go back and forth. Okay, and it should be true statements when you go back and forth. All right. Logs always relate back to exponential equations. You must be able to convert each exponential into logarithmic form and vice versa. So down here are some examples. So again, if you use the heart method, 3 to the 4th equals 81. And 3 to the 4th equaling 81 is a true statement. That is a thing, right? Same thing if we go to the next one. 4 to the 3 halves equals 8. Well, this is really the square root of 4 to the 3rd. Square root of 4 is 2. 2 to the 3rd is 8. So that is a true statement. Now remember, when you go back and forth, you can also go in the other direction. So log base 5 of 1 equals 0, which is what it says over here. And 3, log base 3 of 1/3 is -1, which is what we have over here. Okay, so the heart method goes both ways. I know this is a very deformed heart, but you get the gist. So we are going to write each in logarithmic form for the first one. So I know I'm going to have log, and I encourage you to do a cursive L. Otherwise, this kind of looks like 10G, right? So I would put a little cursive L, but you don't have to. So log, and again, the base is a base is a base. It always stays a base. So log base 3, and make sure that is lower than the log. Okay, of 9 equals 2. Same thing on the next one. You're going to have log, and our base is 16, so it stays 16. And it's going to be of 1/2 equals -1/4. The next one says rewrite it in exponential. So it's the same thing. We are just going to write it as an exponent. So this would be 2 to the 5th equals 32, which is a true statement, so we know we did that right. Next one is 4 to the -1/2 would be 1/2, which is basically saying the square root of 4, which is 2, but negative, meaning that it would be, oh, it's positive 1/2 in the denominator. Okay, so we're just going to work with this. This is a very, very important thing that you are learning today. You are going to use this for the rest of the chapter, so you need to feel comfortable with rewriting this. The next part that we're going to talk about is evaluating logarithms. So when we evaluate it, you can type certain things into your calculator, but in this case, we are going to do it a different way. Okay, when we're evaluating it, I want you to think about finding x. Okay, so we can rewrite it as a exponent, right? So if we use the heart method, we would get 2 to the x equals 16. So then we think, all right, 2 to what power is 16? Well, that would be 4. And the way that we can think about it is we have 2 to the x. So we need base 2 for 16. Well, 2 to the 4th is 16. So we would drop the base and x would be 4. Okay, and that's what we did in 8-2. Same thing with the next one. We want to rewrite it as an exponent. So 7 to the x equals 1/49. So we need to rewrite these both with base 7. So we have 7 to the x, and 1/49 is 7 squared, but remember that's a negative because it is a fraction. So we drop the base and x is -2. For c, again, we set it equal to x. We have 25 to the x equals 5. So obviously we need to rewrite these as base 5. So this first one would become 5 squared to the x, and this one is just 5 still. And we can drop those bases. So we're left with 2x equals, hopefully we realize this is a 1, not a 0, right? If it were a 0, that would mean this whole unit would be 1, not 5. Okay, if there's no number there, it would be 1. This means that x is 1/2. All right, so I encourage you to pause this and try these 3, and I am going to just write out each one of these pretty quickly. So letter D, you'd have 2 to the x equals the 5th root of 2, which you might have needed to rewrite. Remember, we can take that 5 and put it in the denominator. So this is really 2 to the 1/5, which means x equals 1/5. The next one, we have x to the 7th equals 7, which means x would have to equal 1. Again, if there's nothing written there, it would be a 1. And the last one would be 5 to the x equals 1. Well, this was kind of like what I was talking about above, and maybe this was a little tricky. But remember, these would have to be the same base. And the only way to get 1, you would have to have 5 to the 0. So the only way for x to be, or for 5 to become 1 would be if the exponent was 0. Okay, and this is true for any number. It doesn't have to be just 5.